All right, so solving trig equations is a lot like solving all the other equations, right? We're trying to get the x by itself. That's what our goal is, right? So the steps that Mr. Passwater has for us here, you're going to isolate the trig function on one side of the equation. So we're trying to get the whatever trig we have all by itself on one side of the equation. Then we find the corresponding angle measures on the unit circle that satisfy the given equation. Consider any domain restrictions and write the solutions or the general solutions. So let's just go through one of these problems. We want to get the sine value by itself first. So I have 6 sine theta equals 3 root 2. So for this, I need to divide by 6 on both sides. And so I will get sine of theta equals, whenever you're reducing here, the things on the outside of the roots can reduce and the things on the inside have to stay the same. So the 3 and the 6 reduce to 1 over 2. So we would get square root of 2 divided by 2 because we're just like dividing by 3 here and dividing by 3 here. And we get root 2 over 2. Now, it just says what are all values of theta. So if it says all values of theta, it's not restricting any domain, which means that you're probably going to need the plus 2 pi k on this one, right? So when you see all values, then we need that plus 2 pi k for the general solutions. And that's about all they're going to tell you that lets you know you've got to put that little extra piece on there instead of just listing your unit circle values. So if we think about the unit circle, we are thinking about where sine of theta equals root 2 over 2. One spot is right here. It's your y coordinate at pi over 4. So one of our answers is going to be pi over 4. I'm going to come back and do the general solution stuff there in a second. And then the other, again, we're y coordinate. We really just solved this whenever I was showing Evan, kind of trying to explain his question there. Negative root 2 over 2. Root 2 over 2 is over here in the second quadrant, and that is at 3 pi over 4. So x also equals 3 pi over 4. So these are the values from the unit circle. If this question was like the next question where it restricted you to the unit circle, you would be done. But they say all values. So while pi over 4 is an answer, we could also spin all the way around back to pi over 4 by adding or subtracting 2 pi. So I'm going to put plus 2 pi k with both of these answers and say where k is an integer. So this would be our answer. Much like what you were doing last night, we just got that little extra. You gotta work at it just a little bit more. Okay. For 5, we've got f of x equals 3 plus 2 cosine x. G of x equals 2. In the xy plane, what are the x coordinates of the points of intersection of the graph of f and g for 0 to 2 pi? So this is a calculator inactive question. You can't graph it and look at it. They love to do these types of problems on the AP exam. It's kind of a word problem, but what do we have to do to find points of intersection? We just set them equal to each other, which essentially just sets up an equation that we're solving, all right? So I've got 3 plus 2 cosine x equals 2. And then I need to basically solve this for cosine and then think about my unit circle. So, Aiden, what would I do first for this? Perfect. So we'll get 2 cosine x equals negative 1. And then what would I do after that, Aiden? Nope. Divide by 2, yeah. We get cosine x equals negative 1/2. And so really, like a lot of this, it feels like it should be more complicated, but a lot of this is just like, it's not much different than if you're solving 3 plus 2x equals 2, right? Until you get to this part right here. So when you get down to the trig function by itself, we got cosine x equals negative 1/2. Now we're thinking about the unit circle. So on that unit circle, right, cosine is my x coordinate. I'm going to have a negative 1/2 right here, and I'm going to have a negative 1/2 right here, because right here I will have negative 1/2 root 3 over 2. That is at 2 pi over 3. And right here I will have negative 1/2 root 3 over 2. And that is at 4 pi over 3. Now this one tells you that you're looking from 0 to 2 pi. So you're just looking at unit circle values. So you're just going to get, most of the time it's going to be 2 answers. Sometimes it may be more. Occasionally it will be just 1 answer. But you're not going to put the plus 2 pi k. All values tells you you need to put that plus 2 pi k. So we're going to have x equals 2 pi over 3, and x equals 4 pi over 3. There. Okay, questions? All right, let's keep moving. You see a notation alert right here. This is a really important one to pay attention to. If you have a sine function that is raised to a power, then another way that that can be notated right here is to put that power right behind the sign. The one we most typically see is sine squared. So whenever we see it written like this, like you can see right here, we see sine squared of x. Especially here at the beginning, I think it is going to be helpful for us to rewrite that as sine of x squared. Okay, that's what that means. I think probably mathematicians were trying to avoid excessive parentheses within a problem. Because sometimes we have like expressions right here as well that need parentheses. So they decided, hey, what if we just put the square right here to show us that the whole thing is being squared? So that's just a notation alert. So let's look at what this looks like in example 6, because we've got a sine squared here. So the function g is given by g of x equals 3 minus 4 sine squared x. What are the zeros of g on the interval from 0 to 2 pi? So if we're looking for zeros, what should we do with this equation? Set it equal to 0. It's like where our y-coordinate is 0. Those are our x-intercepts. So we're going to have 0 equals 3 minus 4. And I'm going to do this. Sine of x squared. At least right now, because I think it helps you see what is happening, right? You can do this every time if you would rather, or just know that this is what it means here. So we need to solve this equation for the x, which means we need to get sine by itself. So, Asher, what's the first thing we would do here? Good. We'll subtract that 3. So I got negative 3 equals negative 4 times sine of x squared. What would you do next, Asher? Divide by that negative 4. And so that's going to give us positive 3/4 equals sine of x squared. All right, what next, Asher? Good. How do we get rid of a square? Square root. We are square rooting both sides. Now, there is something we must do when we square root both sides. when we square root both sides, I need something else with my square root of 3 over 4. What is it? What? It doesn't really matter what number is underneath that root. It's not an I. I would be if we have like a negative under a square root. You have to put a plus or minus. Right. Remember, like, let me go over to the side and just do like an easier one. Like if you've got x squared equals 9, right? And you square root both sides, the square root of 9 is 3. So 3 squared equals 9, that is true. But negative 3 squared also equals 9, right? So anytime you square root both sides of the function, let's make ourselves a note right here. If you square root both sides, you must put plus or minus there. And what that's going to do is it's going to give us like twice as many answers in most cases here. So now, is the square root of 3 over 4 or negative square root of 3 over 4 on our unit circle? We don't have that. But when we have square roots, we can just square root the top and square root the bottom. Okay? So I'm going to still have my plus or minus. And then I cannot take the square root of 3. But can I take the square root of 4? I can. Square root of 4 is 2, right? And that 2 will no longer be under the root because I've taken the square root of it. Do I have square root of 3 over 2 on my unit circle? Yes. Because I've got that plus or minus, I am looking for anywhere sign is positive root 3 over 2 or negative root 3 over 2. So, for sine, that's your y coordinate. That is at pi over 3. It's also going to be at 2 pi over 3. And 4 pi over 3. And 5 pi over 3. Because like our coordinates here are 1/2 root 3 over 2. Right? And our coordinates here are negative 1/2 root 3 over 2. And down here, negative 1/2 negative root 3 over 2. And over here, 1/2 negative root 3 over 2. So I'm going to have 4 answers because I'm using the positive and the negative of these. So if you forget that plus or minus, you're going to miss half of the answers on these types of problems. They did tell us just to restrict to the unit circle here, so we're just giving our unit circle values. So we will get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All of our pi over 3s will be our answers. You could list them all separately, like x equals pi over 3, x equals 2 pi over 3, x equals 4 pi over 3, x equals 5 pi over 3. You may see it like that as well. I think so. You may see just like brackets and then those 4 listed for that. That would be okay. All right, questions? All right, let's take it up one more notch, and then we'll be about ready to go. So let's look at 7. It says, what are all the values of theta for 0 less than or equal to theta less than 2 pi, where cosine squared theta equals negative cosine? So this problem is a little different than any of the ones we've seen before. Because all of the other problems just had one trig function, right? They just had, like, here was sine, there was a single sine. Here we just had a single cosine. Here we did have a square, but there was still just one of them, right? But now I've got a cosine squared and a negative cosine. So any ideas on what I could try here? They won't cancel. So, because this is like a square, it's not like 2 cosine. It's a square, so it's like having x squared and x. We can't put those together. So they won't cancel. If you divide off the negative, it's just going to move it to the other side. So you could, but it's not really going to help you like get anywhere with it, because it just kind of like moves it over. It would, and it would help out here. I'm gonna do this, but don't follow me. This would help out here because we would get cosine of theta, right? But over here, we would get plus or minus the square root of negative cosine of theta, which makes that side terrible. So while it does help us on one side, it's not going to be that helpful in the grand scheme of things. Okay, other ideas? Okay, because like when we have quadratics, because I was about to just change things to quadratics, right? When we have quadratics with something squared, we move everything to one side, right? So I could do cosine squared theta plus cosine theta equals 0. And so like if I had x squared plus x equals 0, how would I solve that? If it were just x's. With quadratics, we move everything to one side, then what do? We factor. How do I factor this one? It's not normal like X method factoring, right? It's actually kind of like easier factoring, but kids forget it. I would do a GCF. I would like pull an X out, right? And so that'd be X plus 1 equals 0. So this is sort of like a parallel problem to what we're looking at. The difference that we have here is that instead of like just a single variable, we've got cosine. But we can still factor cosine like it's a variable, like it's an x. So that's what we want to do. We want to do cosine of theta times cosine of theta plus 1. And so this is still equivalent, right? Because if I multiply it back, if I were to multiply it back, cosine theta times cosine theta is cosine squared. And then cosine theta times 1 is cosine. We're okay here. All right, then let's go back over here. If I was solving this equation, what would I do next? If it was just the x's. If you divide the x off, you'll lose an answer. You'll lose an answer there. We would set each one of these equal to 0. So x would equal 0 and x plus 1 would equal 0. In fact, we might do this part right here in our head, like subtract the 1 and get x equals negative 1. Those would be our two answers, right? So let's write this down. Move to one side, factor and set equal to 0. And then solve. If necessary, like the x equals 0 didn't have to be solved, right? So we're doing the same thing, but with that cosine in there. We moved everything to one side. We factored. Now we're going to set each one of these equal to 0. So I get cosine. of theta equals 0, and I get cosine of theta plus 1 equals 0. Now the first expression I could go straight to the unit circle from. The second one, what do I need to do first before I can look at the unit circle? Subtract that 1. So cosine of theta equals -1. So what we have to do here that we don't have to do if it's just a regular quadratic is now we've got to go to the unit circle and figure out where this happens. So cosine is my x-coordinate, right? And so that x-coordinate is going to equal 0 right here. And right here, right, these two spots right here. So that is x equals pi over 2 right here, and x equals 3 pi over 2 right here. Okay, so those both come from the first equation, cosine of theta equals 0. Then I also need to think about where cosine of theta equals -1. That's going to happen over here, -1, 0. So for this one, we're looking right here. And that is just at pi. So I also get x equals pi. So these three right here would be my answers. Okay. Questions so far? All right, we got one more here. They're asking for points of intersection again for this. What do we do when we're looking for points of intersection? Set them equal, right? So it's just a way of them making your equation just a little more advanced. Now, I do want to point this out so you can write down what I've written down here. Don't do what I'm getting ready to do next. What some students want to do is they want to say, well, I've got signs on both sides. What if I just divide by sign? Right? Then I would have, like, one of these signs would cancel up here, and I'd have 2 sine x equals the square root of 3. That feels pretty good, right? This will cause you to lose an answer. So we don't want to divide by sine or cosine. It is going to cause us to lose, or we don't want to divide by sine or cosine where it would cancel something out. It's going to cause us to lose an answer. Instead, we want to do like we did on the last problem. So this, is not, I'm going to leave it right there because it's a good note to have, but we don't want to divide both sides by sine or cosine and cancel it out. It'll give you one of the right answers, or maybe 2 if there's 4 answers, but you're going to miss an answer if you do that. So what we want to do instead is we want to do our 2 sine squared x equals square root of 3 sine x. We want to do like we did with the quadratic. Here we got the quadratic, right? Move everything to one side. So we've got 2 sine squared x minus the square root of 3 sine x equals 0. What would I do next? Factor out a sine because we've got signs with both of these. So we'll have sine of x, and then we'll have 2 sine x minus the square root of 3. Right, we're just taking one of the signs away from each of those. Okay. Then, so we have moved to one side, we have factored, we need to set each factor equal to 0. So we will get sine x equals 0. That one's ready for the unit circle already. And then we get 2 sine x minus the square root of 3 equals 0. The second equation is not ready for the unit circle there. So to get that one ready for the unit circle, Layla, what would we need to do there on this? We want to divide by 2, but I would do something else first. By how? Huh? Add it, yes. So we got 2 sine x equals the square root of 3. And then we can divide by 2. And so sine x equals positive square root of 3 over 2. So when you get to this point, you're looking at the unit circle. So at first I'm thinking of where sine of x equals 0. So that happens right here and right here, right? It's y coordinate. This is 1, 0. This is negative 1, 0. And so that is at 0 and at pi. So I'm going, for this one, I'll get x equals 0. I'll get x equals pi. Should I use 2 pi? Okay, Zane's got it right here. 2 pi is an answer, but look at your restrictions right here. Do you have a or equal to sign right there with your 2 pi? You do not. So 2 pi would make this equation true, but it's not in the restricted domain that they gave you. So, so just use 0 and pi for this. And that is usually how they do it. You can see this is also the case right here because using 0 and 2 pi is sort of redundant. They're coterminal angles there. So that's usually what they'll do. That's for this equation. We also need to know where sine of x is root 3 over 2. So sine is y coordinate. That happens right here, 1/2 root 3 over 2. That is at pi over 3. Where else? So we got x equals pi over 3. Where else does that happen? What? 2 pi over 3. Very good. Right there at 2 pi over 3. We would have negative 1/2 root 3 over 2. And so we got these two spots right here. We get 2 pi over 3. Okay, questions? All right, so that worksheet night to start looking at those 3A test corrections before they get too old and you forget everything about them. All right, so here we are going to be looking at what to do if we have inequalities. So we've looked at equations, right? We also need to look at what happens if we have inequalities, less than, greater than signs instead. So there are several ways we can think about solving inequalities for trig functions. We can think about looking at them from our graphs. We can think about looking at them from the unit circle. Or we may need to do a little bit more advanced tactics, like we'll see at the very end of these notes. So if here we have the graph of f is defined from negative pi over 2 to pi over 2, what are all the values of x for which f of x is less than or equal to 0? Okay, so they didn't even tell us what graph this is. What graph is it? That's sine right there, right? But it doesn't necessarily even matter. This is a good review for any type of inequality where they give you a graph. Okay, so if a function is less than or equal to 0, what are we looking for on the graph? Below the x-axis, right? This graph is negative, negative meaning below that x-axis. So I wouldn't try to reason anything other than looking at, oh, it's from here to here and from here to here, right? So when you're reporting this, remember you always have to give x coordinates. You're looking at the x-axis for this. Actually, is this just straight sine? It has an amplitude of 2, doesn't it? I just realized that. So it is 2 sine is what we're actually looking at here. But again, not really important for what we're doing here. So we are just going to say, you can either write it this way. Notice that we have an or equal to sign. So I'm going to do the brackets, negative pi to 0, and pi to 2 pi. If I had a less than sign there, I would use parentheses instead of brackets. Or you can write it this way, negative pi is less than or equal to x less than or equal to 0 with pi less than or equal to x less than or equal to 2 pi. So you can use either type of notation here. They're going to accept either one. There, you don't have to have them both. So it doesn't matter what graph they give us. It doesn't have to be a trig graph. It could be an exponential. It could be a log graph. It could be a polynomial. It could be a weird piecewise function that they've just given you. You're just looking for where this graph is below the x-axis. Yes? For this problem, they have restricted our domain from negative 2 pi to 2 pi. So because they have said that right there, we're just given these two answers. If they did not do that and told us this was a periodic function that continues, then we would have to worry about some plus 2 pi case. I'm hoping that we don't see that. I don't recall seeing problems like that because it does make it where you're already doing intervals. It makes it much more difficult to express that. So I think they'll probably give you a restricted domain on these types of problems most of the time. I could be wrong. Could be blocking out some problems there. But all right, questions on that? All right, so if we're given a graph, we're just looking for where the graph is below the x-axis, or it could be above the x-axis if we have greater than 2. But a lot of times we're not given a graph, and it might not just be 0. So we might see a question like this. What are all values of theta from 0 to 2 pi for which sine is greater than or equal to square root of 2 over 2? Okay, so he goes to say sine is the vertical displacement from the horizontal axis. Vertical displacement from the horizontal axis, that's your y coordinate. Right? We are looking for all possible angle measures where the y coordinate is at least root 2 over 2. So, if you look over here, okay, he's given us the unit circle. And I can tell that sine, my y coordinate, is square root of 2 over 2 here, and the square root of 2 over 2 here. Okay? If you want, you can connect those with a line. Right? We can go from here to here. My y coordinate, square root of 2 over 2 here. I am looking for anything that has values above that. Right? So my y coordinates above these points are going to give us values where sine of theta is greater than or equal to square root of 2 over 2. So you always want to start, like the unit circle begins right here at 0, and then you go counterclockwise. So you're starting over here at 0. These are not answers. Right here at pi over 4, that's where our answer begins. So we would say pi over 4 less than or equal to our theta less than or equal to. Then keep, these are all answers, 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 answers. Right here is where we go back. That's our end point, 3 pi over 4. Or you could write it like this, pi over 4 to 3 pi over 4, like that. So if you don't have a graph, I think the unit circle is much more helpful for this. Okay, questions? All right, let's keep going. All right, so we've got f of x and g of x. What are all values in the xy plane from 0 to 2 pi? They're restricting our domain, thank goodness, so we don't have to do all solutions. We don't have to do plus 2 pi k, for which f is less than g. So we're just taking f and g and plugging that in, right? F is less than g, so we're doing 4 plus 2 cosine x is less than 3. So a lot of this is just like solving the equations that we were doing earlier. Braden, what would I do first to solve this? Good. So I got 2 cosine x is less than -1. Delilah, what would I do next? Very good. So I got cosine x is less than -1/2. Now at this point, if it was an equation, I would just look at the unit circles and give the values where this equals. I really need to think about my whole unit circle here. I want to think about where cosine x is less than -1/2. Cosine is my x coordinate, right? What? Oh, we do not have to flip the sign here because we divided by +2. So it was the top number that was negative, so we do not have to flip the sign. But if we had divided by -2, we would have to flip the sign for that. Okay, so if it's got to be the number you're dividing by for it to flip the sign. But I'm glad you mentioned that because I was definitely ignoring any sign flipping. But we don't have to here because the number we're dividing by is positive. So we've got -1/2 x coordinate. So that happens right here, right? So like right here at 2 pi over 3, we've got -1/2 square root of 3 over 2. And then we also have that happen right here at 4 pi over 3. Coordinates here are -1/2 negative square root of 3 over 2. So these two spots right here are the places where cosine of x equals -1/2. And I want values less than this. We're talking about x coordinates. I think it is helpful for you to connect these two with a line. Okay? And then we are looking for less than. So when we're talking about the x coordinates, when we're doing cosine, we're thinking about the left side would be less than, the right side would be greater than. So we're talking about less than, so we're looking at this section of the unit circle. So to give your answer, you always start over here at 0, and you go around counterclockwise. So not our answers here, right here, 2 pi over 3 is our first piece of our answer. I'm going to use a less than sign this time, not a or equal to, because I only have a less than sign, right? Then all of these over here are answers until I get around to 4 pi over 3. Or I could give my answer like this, 2 pi over 3 to 4 pi over, oh, that's wrong. It's not going to be a bracket, is it? Parentheses, 2 pi over 3 to 4 pi over 3. Okay, let's see if we can get example 4 done, and then we'll stop here for today. So we are looking for where h is greater than k for this one. So that is going to be 3 cosine x is greater than square root of 3 plus cosine x. Now, This one kind of looks like one where we need to move in factor. But do I have any squares? No. So I need to get my cosines together. This is like a 1 cosine x. So I'm just going to subtract that 1 cosine x. And so this is like having 3x minus 1x. I get 2 cosine x is greater than the square root of 3. And then, Matthew, what do I need to do next? Divide by 2 to get that cosine by itself. So I'm getting cosine of x is greater than square root of 3 over 2. So we're going to the unit circle here. Cosine x coordinates, we get right here, we got square root of 3 over 2, 1/2. So we're looking at this point. That is at pi over 6. And then also, right here, at 11 pi over 6, I will get positive square root of 3 over 2, negative 1/2. Now, I think it's helpful, just like we've done on the others. Draw yourself a line connecting those two. We are looking at greater than this time, right? So whenever we're dealing with the x coordinates, like we are here, we have that vertical line, greater than is everything to the right. So the answers are over here. However, you have to be careful on how you give your answers here, because they told us that we are looking between 0 and 2 pi. So my answer looks like a pi over 6 to 11 pi over 6. But it's not. Pi over 6 to 11 pi over 6 would be all the parts that are not the answers, right? So when you're giving the answer here, you always want to start at 0, right? So from 0 up to pi over 6, those are answers, right? So I would have, actually, I can use a bracket at 0, because at 0, that is one of my answers. It's not an endpoint. So I can use a bracket at 0 up to pi over 6, which is a parentheses, right? So I'm starting here. I'm going this direction. I've got that part of my answer, but then I've got this big gap over here where these are not answers until I get back around to 11 pi over 6, and then 2 pi. And I can use a bracket at 2 pi because 0 and 2 pi are like right in the middle of the answers. The edges, the endpoints, I've got to use parentheses with those. All right, so go ahead and pack up. We will finish